Activated carbon is a well-known technology that's been used for centuries for the treatment of water to improve its quality. It achieves good treatment, but it does have a number of disadvantages in that when the material is fully loaded, it has to be disposed of or regenerated. If it's disposed of, it will be disposed of to landfill or incinerated, or if it's regenerated, it'll be a thermal regeneration process. That's a high energy, high cost process, and you lose around 5 to 15% of the starting material.
Well, activated carbon, as you know, comes from the oak tree. So if it's not expensive to make from the first place now, it will be expensive in the future. And I can assure you that the regeneration process is very expensive and very energy intensive as well, because it involves introduction of chemicals or by thermal regeneration. So eventually activated carbon has immense hidden costs in terms of regeneration or production in the first place.
The Nyex adsorbent is very different in that it is a lower capacity adsorbent, but because we're continuously passing current through it, we're continuously regenerating the material so that you don't have that problem of it ever becoming fully loaded. It's always being regenerated.
When you compare the Nyex system with granular activated carbon, there's some clear advantages. Activated carbon degenerates, whereas the Nyex system offers a consistency in performance. There's a confidence in the level of removal that can be achieved throughout your manufacturing process. Secondly, as the activated carbon degenerates, it reaches a saturation point. At that point, it's going to need an intervention. It's going to need to be removed and replaced, which causes downtime in your production process. Again, Arvia works and regenerates in situ, providing manufacturing benefits. I would also argue that by the fact that activated carbon needs to be taken off-site to be regenerated, there's an additional cost.
What you find is a lot of other technologies available will move that problem somewhere else. They'll trap it and move it. We try and face the problem head on and turn those organics into water, carbon dioxide, hydrogen and gas.
Well, for thousands of years, people have been using various types of carbon to clean water through adsorption. The difference we have now is, rather than throwing all that away and paying for the cost of transportation and incineration, instead, we're cleaning the system, as well as other bonuses of having electrochemical reactions in the reactor itself. So, in simplest terms, I like to tell people we build filters that clean themselves, but really it's much more clever than that, and there's a lot more goes on in the reactor.
We will always work with the customer in advance of designing a system for them to ensure that the system that we are supplying is the best system for that customer. And if we don't think it's the best system, we will often make recommendations on the type of system that they should be using, because we specialize in certain applications and there are other technologies that are better at different applications.
I would encourage any company in any industry to approach Arvia for a conversation. We have a team of experts here that are passionate about getting high quality wastewater. We have a database of experience where we've looked at a number of different micropollutants and organics, and we have evidence to prove that we can treat to very low levels.